All right, everyone ready to get back into the unit circle? So we're going to apply what we learned about the unit circle and how, like why it's useful, how we use it in trigonometry. And basically the unit circle allows us to do trigonometry without using a calculator, which is pretty cool. So I do have my unit circle that I filled out on handy. So if you guys want to have out that homework that you guys had, this is what I'll be referring to, and you'll be using this for homework as well. Okay. So we're doing 6.4 today. And this is kind of going to be your warm up today because there are actually three more trig functions. And so these are the first three that we know: sine, cosine, and tangent. So of course, we know that sine is just equal to opposite over hypotenuse. And then applying that to the unit circle, that's why we see the y over the r, right? And then we know cosine is adjacent over hypotenuse, but applying to the unit circle, it's x over r. Oops, that's a y. That's supposed to be an r. And then for tangent, it's opposite over adjacent, or y over x. Okay, so there are actually three more, and these are called the reciprocal trig functions. So if you will notice, this one, CSC, the way we pronounce that is cosecant. And cosecant is the reciprocal of sine. Okay, so you'll literally notice that if sine is y over r, cosecant is its reciprocal. It's just flipped, r over y. Okay. Cosine reciprocal is called secant, or SEC for short. Okay, so these are reciprocals of each other. And then finally, tangent's reciprocal is called cotangent. I know in terms of names that makes the most sense. These ones may be tricky for you guys, but we do need to identify these two. So sine goes with cosecant, and cosine goes with secant, and tan goes with cotan. And it's literally just the reciprocal or the flip ratio of its reciprocal. Okay, so that's all of the trig type of functions. There's a total of 6. Okay, and that's it. Right? So really quickly, we're just going to do a quick little example here. So we're going to write all 6 trig ratios using this coordinate point. So that does mean that we have to draw a picture. I guess I should have started from just scratch, because how do you guys know? We'll actually go here. So do you guys see how this is -4, 3? So on a coordinate plane, what quadrant would that fall in? So if we go left 4 and up 3, so left 4 and up 3, that would fall in quadrant 2, right? It's no other quadrant. So that's why we draw our triangle. So we're going to connect that point to the center. So again, like this is like a circle, right? Connect it to the center. Drop this down. Always drop it down to the x-axis. Make a right angle, and there is our right triangle. So that's why I drew it like that, instead of this way or that way. That would be a quadrant 4 if it ended up in quadrant 4, or drawing it this way for quadrant 3. So those are the 4 different types of triangles that you can draw depending on where your coordinate point lies. This one happened to lie in quadrant 2, so that's why we draw the triangle like that. Does that make sense? Okay. So theta will always go right at the center of the circle, right there. You will always place your theta there, okay? And then here's our point, -4, 3. So that means that this length is -4, right? This length is 3 because we went left 4 and up 3. And then if we did the Pythagorean theorem to find the missing side, the hypotenuse, 3 squared plus -4 squared, so that's 9 plus 16 is 25. The square root of 25 is 5, so this is 5. Okay? So if we want to write the 6 trig ratios, we have sine, which we know is y over r, or opposite over hypotenuse. So that's going to be 3/5, and that's it. Okay, so they just said to write the ratio, so this is a ratio. Then cosine is x over r, so that's -4/5. And tangent is y over r, or opposite over adjacent. So that's 3/-4. So that's the first 3, but they want a total of 6. So the other ones are the reciprocals. So the reciprocal of sine is cosecant, and we're literally just going to take this and flip it, and that's the answer. Reciprocal of cosine is secant. We're just going to flip that. And the reciprocal of tan is cotan. So we're going to flip that. Like so. Okay. So that's all they want us to do. We only care about the reciprocals. If we went back and applied that all students take calc because we wanted to know how large this angle was, we would take sine, right? Because that would give us a positive angle. All right, so now that we are familiar with the 3 other trig ratios, we are now going to apply this to the unit circle. So I am going to show you guys how to evaluate something like this without using a calculator. Okay, so of course, easy, we can pick this up, it's in degrees, and we can say sine of 300 is equal to -0.86 or 0.87 if you round to the nearest hundredth. Okay, but let me show you how to get that same answer without using a calculator. Okay, so again, we're going to be using the unit circle. So there's a few different ways that you guys can solve for these problems. You could either first fill out the unit circle, or even just the portion that you need, okay? This is the first way to do it. And we're taking sine of 300, right? So I'm gonna go find 300 on my unit circle, which is right here, right? So it's all filled out because we already filled it out. So here's 300. And if I want to take sine of 300, well, what does sine equal to? Like, what is the ratio for sine? Sine is equal to y over r, right? But what is r equal to on the unit circle? Just 1. So it's y over 1, which is just y. So how would I find the value of sine at 300 degrees? Well, I go to 300 on my unit circle. I look at my coordinate point right here. This is the x and this is the y. What is sine equal to? Y. So guess what sine of 300 is equal to? The y value of the coordinate point at 300 degrees. That's it. That's what it equals. So what this means is that sine of 300 is equal to this, -√3/2. Now, of course, that's as a fraction and not a decimal. So remember when we did sine of 300 and we got -0.87? Well, what's -√3 divided by 2? It's the same! Isn't that kind of cool? So that's how you guys calculate trig using the unit circle. So that's one way to do it if you guys have your unit circle handy and on you. Of course, that means that you actually have to have this memorized or fill out the unit circle But I do like to use the unit circle just because I usually always have it on hand during this module, and you know, I fill it out so many times that I have it memorized. So I like to use the unit circle for these problems. But how would you do this without the unit circle? We would do what we just did over here. Hey, Jax. So we would, let's see if I can grab some room, draw ourselves a little coordinate plane. Now you need to know where would 300 degrees lie in which quadrant. So again, if this is our initial ray and we open up an angle, a positive degree going counterclockwise, this is 90, 180, 270. So 300 is like right about there, right? So if that's where 300 degrees stops, we need to draw our terminal ray, and that's a full 300 degrees, right? So here's our ray, and then we're gonna draw this always straight up vertical to the x-axis, and there's my right triangle, okay? And that's all you guys need, it's just that right triangle. So I'm just gonna redraw it a little bit bigger, like so, okay? So if this whole thing is 300, then how many degrees would the reference angle be? Well, if this is 300 and this is 360, then that would make this 60 and this 30, right? On all unit circles, how big is my radius? 1. And now I can apply special right triangles. So if I know that sine is the y value, that would be here. That's y. So I want to find that value. That's across from the 60 degrees, so I do need to find the x value first. Okay, so we're going to set that 1 equal to its counterpart for special right triangles. If you guys remember, we went over that before. So in a special right triangle, specifically a 30, 60, 90, across from the 30 is x, across from the 90, the hypotenuse is double x, and across from the 60 is x root 3. So we're going to set our hypotenuse of 1 equal to 2x. So if I divide that by 2, that means that x equals 1/2. And if x is 1/2, how much is y? X times root 3, which is root 3 over 2. And then because we went down, it's negative root 3 over 2, which is exactly what we got. So that's how you guys do it, by drawing a reference angle and determining it without the unit circle. But if you already have the unit circle filled out, you see how much easier it is. But both of these ways will work. So either use the unit circle, boom, there's your answer, or draw yourself a triangle in the correct quadrant, find the reference angle, and then use special right triangles to find that value. Okay, there it is. All right, so let's try another one. Let's do cosine of 135. So again, it's just so much quicker. I'm gonna grab my unit circle and I'm gonna find 135. Now, what does cosine equal in the, what's the ratio for cosine? So cosine is x over r, but in the unit circle, the radius is equal to 1. So that's x over 1, which is just x. So at 135 degrees, to find the value of cosine, you just need the x value. So here's 135. Here's the coordinate point, and what's the x value? Negative root 2 over 2. So can you guess what cosine of 135 equals without using a calculator? Negative root 2 over 2. Okay. Let's do a little more complicated for 2 reasons. Tan of negative 210. So first of all, this is a negative, right? So if you guys remember, on the first, in 6.1, we talked about different types of angles. So angles always, positive angles always open up from the initial counterclockwise. Negative angles go again from the initial clockwise. So that's a negative degree. So if I'm looking at negative 210, well, we're going to go clockwise. That's negative 90. That's negative 180. And that's negative 270. So negative 180 plus 30 is negative 210. So negative 210 is the same as 150 degrees. Okay. So in terms of the unit circle. So tan of negative 210 is the exact same thing as taking tan of 150, which, I mean, we can even calculate it. So tan of negative 210 is negative 0.58. And then tan of positive 150, same thing, okay? So on the unit circle, like, of course, these 2 degrees are not equivalent. Negative 210 and 150 are not equivalent. But on the unit circle, taking trig, they are equivalent. All right? So now that we've established what our negative degree is located-wise, so you don't want to go to this 210. That's positive 210. That's starting from here and going counterclockwise. We went clockwise, which is the same as 150. So let's find tan of 150, which is equivalent to negative 210. So, well, what is tan equal to? Y over x, right? So you are literally going to take the y value at 150 and divide it by the x value at 150. So on the unit circle, here's 150. Here's the matching coordinate point. Y is 1/2 and x is negative √3 over 2. Okay? So we're going to do 1/2, that's the y, divided by negative √3 over 2. That's the x. I hate seeing this like quadruple, triple fraction, whatever you want to call it. So I'm going to rewrite this as the numerator divided by the denominator. That's a good little trick. Anytime you guys see something confusing looking like this triple fraction, just write it like this. Because then how do we do a fraction divided by a fraction? KFC. We're going to keep the first, flip the second, and change the sign to multiplication. I can cross cancel here. What's 2 divided by 2? Just 1. So this whole thing equals 1 times 1, which is 1, divided by 1 times negative √3, which is negative √3. And then we don't want to keep radicals in our denominator. So we're going to go ahead and multiply it by itself. And that's going to give us 1 times √3, which is √3, divided by √3 times √3 is just 3, and it's negative. So this is what tan of 150 or tan of negative 210 is equal to. Okay? So all you guys are doing here, no matter what is given to you, all you're doing is, first of all, making sure that you know these. You know that sine is equal to y over r, but you can literally just put y, because on the unit circle, r is just 1. So you're totally just welcome to put y. So sine is equal to the y value of the coordinate point, right? Cosine is equal to x. Tan is equal to y divided by x. Cosecant is equal to, now instead of r over y, let's put 1 over y. It's the reciprocal of this. Secant's equal to 1 over x, and cotan is equal to x over y. So just know those. Know your unit circle, be able to fill this out, and you'll be able to calculate these. Cool, huh? Okay, so let's try just a couple more. Let's see what a secant would look like. All right. So secant, again, is the reciprocal of cosine, okay? So if cosine is just equal to x, or x over 1, then secant is equal to 1 over x, all right? So we're gonna go to 90 degrees, and we are going to take 1 and divide it by the x value of the coordinate. So at 90 degrees, the coordinate point 0, 1, so the x value is 0. So that means that secant is equal to 1 over 0. Can you divide by 0? I can't. So that means that this is actually undefined. So I usually put undef as for shorthand, but you're welcome to actually write it out. Don't put no solution because that's completely different than this. So don't say no solution, say undefined. That's the proper way to say what this is. Okay. All right, let's just try a couple more in degrees and then we'll move on to radians. So now we're going to deal with cosecant. So cosecant is the reciprocal of sine. We know that sine is equal to y. So cosecant is equal to 1 over y. So let's find 120, which is here. Here's our coordinate point, but we're only going to look at the y value, which is positive root 3 over 2. So this is going to be 1 divided by positive root 3 over 2. Then we're going to do some KFC. I'm going to make that into a fraction, 1 over 1 times 2 over root 3. And that's just 2 over root 3. And if we multiply both top and bottom by root 3, this is called rationalizing the denominator. We don't want radicals in the bottom. We get 2 root 3 over 3. Okay. All right. Let's see. What would you do with something like this? Where on earth on the unit circle is 495? The biggest degree I see is 360. So what does that mean? If you guys see a value bigger than 360, that means that from this initial ray, we opened up an angle, we went a full 360, and then we kept going. So this is a huge angle. So the way that I like to do this is take that number, what was it, 495, and subtract 360, which is 135. So 495 is the same thing as doing a full 360 and adding an extra 135, because that totals to 495. So the position on the unit circle of 495 for cotan is equivalent to cotan of 135. That's how you do that. And then we would go in, cotan is x over r. So we would go in, and at 135, our x is negative root 2 over 2 divided by our y, which is root 2 over 2. Happens if you divide something by itself. Like what's 2 over 2? 1. What's 1,000 divided by 1,000? 1. So what's root 2 over 2 divided by root 2 over 2? 1. So what's negative root 2 over 2 divided by root 2 over 2? Negative 1. Okay. All right, so let's get into some radians. You solve this the exact same way. So instead of looking for a degree on your unit circle, we're going to focus on radians. So where's 2 pi over 3? Right here. So 2 pi over 3, we're going to find secant of 2 pi over 3, which is the same thing as 120 degrees. Okay. So for secant, again, that is the reciprocal of cosine. So that means that secant is equal to 1 over x. So we're going to divide 1 by whatever the x value is at 2 pi over 3, or 120, same thing. What's x? Negative 1/2. Then I do a little KFC. What does this multiply to? 2 over negative 1 is negative 2. So the secant of 2 pi over 3 is equal to negative 2. Okay. Let's try cosine of pi. So where is pi located? At 180. And that coordinate is -1, 0. Well, cosine is equal to the x value. What is the x value at pi? -1. So what is cosine of pi equal to? -1. Simple as that. Okay, let's do one more. Let's do cosecant of 13 pi over 6. The highest radian I see is 11 pi over 6. And then we know that 2 pi is the same as 12 pi over 6, right? Remember the counting? So how on earth am I going to find 13 pi over 6? Well, if this is 11 pi over 6 and this is 12 pi over 6, 13 pi over 6. So 13 pi over 6 on the unit circle is equivalent to 1 pi over 6. So if I'm asking to take cosecant of 13 pi over 6, that's equivalent to taking cosecant of pi over 6 because they're in the same position. Okay? Cosecant is the reciprocal of sine, so that means that cosecant is equal to 1 divided by the y value. Now at pi over 6, our y value is 1/2. So we're going to do 1 over 1/2. And if you do KFC, cosecant of 13 pi over 6 is 2. Done. Let's do one more just for fun, because I know you guys are having so much fun and you never want this to end. Let's try tan of 11 pi over 4. On the unit circle, the biggest pi over 4 I see is 7 pi over 4. So if that's 7 pi over 4, we're going to add another pi over 4. And this would be 8 pi over 4, which reduces to 2 pi. That's 8 pi over 4. And we're trying to get to 11, right? So if this is 8 pi over 4, this is 9 pi over 4. 10 pi over 4. What am I getting to? 11. 11 pi over 4. Okay, so 7, 8, 9, 10, 11. So this is 11 pi over 4. So 11 pi over 4 on the unit circle position is equivalent to 3 pi over 4. So tan of 11 pi over 4, we're going to get the same answer if we did tan of 3 pi over 4. Again, watch my YouTube video of the unit circle if the counting is confusing you right now and you're like, what the heck is she doing? Go watch my unit circle video and it'll make way more sense. Okay, so tan of 3 pi over 4. Well, tan is equal to y over x. So I'm going to divide the y value by the x value at 3 pi over 4. So at 3 pi over 4, here's my x and y. So I'm going to divide the y by the x. So root 2 over 2 divided by negative root 2 over 2. What's anything divided by itself? 1. So if there's a negative there, what is tan of 11 pi over 4 equal to? -1. Boom. So that is how you guys calculate trig, any of the 6 trig functions in both degrees and radians and numbers bigger than 360 and negatives. We just went through all of it without using a calculator. Okay? So for your homework tonight, we are going to do RSG 6.4. And you're only going to do the last page. Last page only. So that's on page 12 of the RSG packet. And you'll see numbers crossed off, so you're gonna not do those. So don't do the ones crossed off. You can still skip the ones crossed off. So basically that whole last page is numbers 12 to 26. So I'll put 25. Wait, no, 11. 11, sorry. 11 through 25, and you're going to do the odds only. Okay, so basically the problems that are crossed off, don't do those. Only do the problems on that entire last page that are not crossed off, which is the odds only 11 through 25. Cool? Awesome. Hope that was helpful. Come to office hours if you guys need some more help, and go watch that unit circle video if you need some more help with the unit circle. Have a good day.